Okay, guys, 17.2. We are going to solve quadratics completing the square. Now, remember that we did do factoring for perfect square trinomials, and this was the cookie cutter. This was the cookie cutter pattern: x squared plus 2kx plus k squared. So you have these perfect squares on the end, and when you have these perfect squares on the end, you can get your middle term by taking 2 times the first term and times the second term. And then the same way, it doesn't matter if there's a plus or a minus. That's the only difference in these two patterns. This one has a plus for both the front and the back, and this one has a minus in the front and a plus in the back. Okay, let's look at the board. So I have completing the square up here. Think about this. I'm going to show you the really easy way if you have to do something by completing the square. It's not a shortcut, but it's like the keys to the kingdom that people usually don't tell you for a while. In order to get this back term, so let's say that we have this, x squared plus 12x plus 36. Okay, this right here is a perfect square. This back here is a perfect square. Okay, so if we want to try to figure out what this missing number is, up here we have a missing number in the back. If we want to try to figure out what that missing number is, because we want to have perfect squares on the first and the last term, in order to find what that last term is going to be, we take half of the x, not the x squared term, half of the x coefficient. So half of 12 is what? 6. So 12 divided by 2 is 6. We take half of the x coefficient and we square it. 6 squared is 36. Isn't that what I just erased from there? In order to find out when we have a quadratic and we're completing the square on it, in order to find out what the back constant is going to be, remember there's no variable back there, the back constant, to find the back constant, we take half of the x coefficient and square it. Half of 12 is 6. 6 squared is 36. That's what we did down here. Right here, it doesn't matter if there's 2 addition signs or a subtraction sign and an addition sign. To figure out what this missing number is, we take half of the x coefficient, half of 2 is 1, and we square it. 1 squared is 1. It's as easy as that. And a lot of people take you over the river and through the woods trying to do this a bunch of different ways before they finally just tell you. I don't like to do that. I tried that a couple times. Other people told me they taught it that way, and I tried it a couple times, and I found out that by the time we got to the place where you say half of this squared is going to give you that, people are so damn confused they don't know what's going on. So, completing the square. To get the constant missing term, you take half of your x coefficient and square it. Okay, let's look at another problem. So I'm going to write this up here, and then I have this on a separate piece of paper, and I'm going to hold it up so you can see the entire thing. So get ready. You might want to take a picture of it. Okay. You do not have this paper. Snap a picture with your phone so you can have it right next to you. 5, 4, 3, 2, 1. Okay. This is different from the examples that we just did because this is not a missing term right here. Okay? So the instructions for this would be solve. Okay? And when we did these problems the other day, we did what? We factored these, correct? Yes, we did. We're not going to do that. We can try to do that if we want to try to factor this. We could do our setup and see. So, factor it out to 2 binomials. Our a is going to have to be x. And then, so we need the factors of 7 that when they're added up give us 6. So 7 times 1 is 7. 7 plus 1 is not going to give us a positive 6. This is not going to work. We cannot, and I have this written down here, We can't just factor. No factors of positive 7 add up to 6. So we can't factor like we usually do, okay? So when we get to that point, we're like, oh crap, what am I going to do? Well, factoring into two binomials is not going to work at this point. So we're going to solve for our x. How are we going to do that? Oops, technical difficulties. How are we going to do that? We're going to start by moving the constant to the other side. It's the very first thing we're going to do. So we got this problem. The instructions say solve. We looked at it and we said, okay, let's factor. We tried to factor, but we don't have any factors of 7 that will add up to 6. And that's why we said, okay, we're going to try another method. This is a new tool in our toolbox. The first thing we do is move the 7. So the first thing we do is move the constant. So we're going to move 7 to both sides. Now we have x squared plus 6x equals negative 7. Now this is where, I didn't leave enough room. This is where we're going to have our blank. This is where we're going to do completing the square. Why? Because once we move the 7 and we're left with this on one side, our x squared and our x, there's nothing else we can do in this entire mathematical world except complete the square. That's the only thing we can do now that we have it in this form is complete the square. So we do what? Half of 6 is what? 3. 3 squared is, should I write that down? Half of 6 is 3. And 3 squared is 9. Now remember, what we do to one side, we have to do to the other. If we add 9 to this side, because we completed the square, we have to add 9 to that side. So let's rewrite what we got. We have x squared plus 6x plus 9 equals 2. Because that's negative 7 and positive 9. Now we can go ahead and factor into binomials. So we've got these perfect squares. So when we factor this down, and you can write it out twice. This is what I've been doing in a lot of my classes, and people follow it, and it goes really well for them. So our a's are going to be x. We know that since we have two additions up here, that our inside signs are going to be plus. What is our back number going to be? Well, 9 is a perfect square. 9's a perfect square of what? 3. And that's where we usually write this, like this. Okay. So we were given this. This is our original problem. We were told to complete the square. So that instruction right there tells you should kick this to the other side. But I know some people, y'all want to be salmon swimming up the stream the wrong way. So that's why I tried to factor it into two binomials up here to show you that it wouldn't work. Then we went ahead and we completed the square. We took half of the 6 because that's the coefficient on the x. Half of the 6 is 3, and we squared it, which is 9. What we do to one side, we have to do to the other. So we get down here, and we're ready to go ahead and factor into two binomials. So it's going to be 2 of the x plus 3's. And I went ahead and I wrote the way you're used to seeing it in the book. Now, hopefully you're looking at this and you're going, well, there's only one thing I can do with that, right? Because this is an expression, this is a binomial that's squared. I have to get rid of that square. How do I do that? I do that by taking the square root of both sides. When I take the square root over here, it just leaves me with the radicand. So x plus 3 equals radical 2. Now remember, it's not just radical 2. It's positive, negative radical 2. We're almost there. Hang in there. It's all written out on here. So remember, we're solving for x. We still got to get x by itself. How do we do that? We got to get rid of the 3. How are we going to get rid of the 3? We do the opposite. So where it's plus 3 up there, we're going to go minus 3. We got to do it to both sides. That goes away, leaving me with x equals negative 3 plus or minus radical 2. Now I asked myself, is that my final answer? Well, the only way that it couldn't be my final answer is if I could simplify this down further. What are the factors of 2? 2 and 1. Neither one of those are perfect squares. So I know that that's going to be my final answer. Okay, a couple things. Before you go on and necessarily watch the rest of the video, I highly suggest that you stop and you go back and you go through this a few times, work it out a few times, you working it out on a piece of paper, go back through the steps, through the little notes that I wrote down. It makes, once you do this, I don't know, 3, 4, maybe 5 times, it'll get into your head. It'll start making sense. Oh, okay. Half of that squared is going to give me that. I got to do it to both sides. I can't factor into 2 binomials up here. I got to complete the square. I'll factor down here. Since I'm completing the square, it's always going to factor into this, something like this. So I suggest you go back and you watch this and you actually take this and you know the answer, write it down on a piece of paper and work it out by yourself. Get that down pat and then watch the rest of the video. It's going to make the rest of the video much easier for you to digest. Okay. So, you guys have digested this problem right here. Good. That's going to make the rest of this video easier. So, let me erase this. Okay. Let's do another one just to review real quick. So, you guys should fly through this with no problem. So, this is going to be complete the square. It's going to be solve, completing the square. But this could have just as easily been given to you with just the word solve, and you would have to know exactly what to do. You would look at this and you'd go, oh, look, I have an x squared and an x on one side by itself. So I know that I'm going to complete the square. How do I get this? I take half of this. Half of 8 is 4. 4 squared is 16. What I add to one side, I got to add to the other. Okay. So now I can go ahead and, let's write this down. I don't want to leave anybody behind. We add that together, it's going to give us 21. Now let's go ahead and let's factor that. And that's going to factor into, so I got 2 x's. That's my a, my 2 x's. And since I have a minus and a plus, I know that these are going to be minus. 16 is the perfect square of what? 4. Bring down 21. So I'm going to go ahead and I'm going to clean it up a little bit, write it the way you're used to seeing it. Now what do I do to it? Just like in the other problem, I have to get this square off of here, so I'm going to take the square root of both sides. That's going to leave me with the radicand, which is x minus 4 equals radical 21. Now you should ask yourself, does this 21 have any perfect squares in it? No. Are there any factors that I can break 21 up into? Other than 21 times 1, nothing's perfect. Other than 7 times 3, none of those are perfect. So that's how I know that it's going to stay radical 21. And I don't want to forget my plus and my minus. So now what do? I have to get x by itself by doing the opposite. So I'm going to add 4 to both sides. That goes away, leaving me just with x equals positive 4 plus or minus radical 21. And again, I'm not checking for extraneous solutions because this isn't that type of problem. The types of problems we do that on are the ones that start with radicals in the original equation. So hopefully you just you know, you flowed right through that with no problem because you took the time to look at the other problem first. So, on both of these, both the first problem I had you study and this problem, what is the number in front of the squared term? It's 1. Now, let's look at one. Let's look at an example where the coefficient is not 1, because more often than not, those are going to be the problems that you have. Because you know they never want to give you anything easy. I'm not going to give you a million of the harder problems. There's no reason to. I don't have to see if you know what you're doing. So, I got this plus 16x equals 9. Now, you have to resist the urge to factor 4x out of this. Resist it. Don't do it. What are we going to do? Well, we look at this. Okay, we got to solve by completing the square. Holy cow, we have a 4 here, not a 1. We got to get rid of that 4. How do we do it? We're going to divide every term by 4. Not each side. Not each side. It's every term by 4. Why are we doing that? Because we have to get the x squared term to have a coefficient of 1. That's the only reason we're doing it. That'll go away. Leave me with x squared plus 4 goes into 16 4 times. I'm going to complete my square. And over here, I'm just going to leave that as 9/4. I'm not going to worry about messing with that right now. I'm just going to leave it as 9/4. Okay, let's complete the square. Half of 4 is 2. 2 squared is 4. And what we do to one side, I didn't leave enough room. We have to add over there. Because what we do to one side, we have to do to the other side. So let me write this so we're all on one line. Okay. So now, before I even worry about that over there, I'm going to go ahead and I'm going to factor that into my 2 binomials, right? So it's going to be x plus 2, x plus 2 equals 9/4 plus 4. You can do that as 4 over 1 if you want. That's fine. If you want to go ahead and get its common. So let's do like a sidebar. This is a sidebar right here. If I want to go ahead, because I know some of you guys are still weak with fractions, I can go ahead and get my common denominator, which of course I would use 4. So 4 times 4 is 16. So I can go ahead and add that, and that's going to give me 25 over 4. I can go ahead and do that if I want. So let's clean this up a little bit. Let's go ahead and let's write our x. Whoops, my hand is crazy today. Let's go ahead and write our x plus 2 squared equals, and I'm going to go ahead and I'm going to use the 25 over 4. We just figured it out. Why not use it? Okay, what are we going to do now? You guys know what we're going to do. We're going to go ahead and we have to get that square off of that binomial. So we're going to have to take the square root of both. That's going to leave us with our radicand of x plus 2 equals. Now, hopefully you remember from, this is 17.2, be out of chapter 16. You can write this as 2 radical problems. All right. So we bring our x plus 2 down equals the square root of 25 is 5. The square root of 4 is 2. If you don't remember that from chapter 16, you better go back and review it because you need it. Now, what are you going to do? Well, now you got to go ahead and you got to move the 2. But one thing you have to remember, you took the square root right here. You have to remember that it's plus and minus. So instead of trying to figure out where to put your plus and where to put your minus, I want you to write it like this. Make it really easy for yourself. Just go like this. So you got to move the 2. Now write this as 2 problems. Your first problem will be x equals -2 plus 5 halves. And then write it again. You're going to have x equals -2. This is a plus minus 5 halves. So you're working it both ways. Now, you're going to have to get a common denominator, and I'm going to let you do all that. You're going to get a common denominator on both of these before you subtract. So you could put 2 over 1 plus your 5 over 2. Get your common denominator at 2. I'm going to let you do the other one yourself. How'd I go from 1 to 2? I multiplied by 2. 2 times 2 is 4. So that's going to give us negative 4 halves plus 5 halves, which will give us 1 half. So this one over here is going to give us x equals 1 half. Then I'm going to let you go ahead. I'm going to tell you what this one is, but I want you to work it out. This is going to be negative 9 over 2. I want you to work that out for yourself. So it's not that these are like crazy hard. They just take up a lot of room. Your solution set are both of these solutions. This is your final answer. The solution set of 1 half and negative 9 over 2, 9 halves. And that's one problem. This just took up a lot of space because over here, when you divide in the very beginning, you end up with a fraction. And you know fractions take a lot of space. And you need to remember that you need a common denominator. Common denominator. To add and subtract fractions, you need to write that down, and you need to remember that, because that's going to be one of the places that people are going to make mistakes on this, and they're going to do terrible on this test. You have to remember you need a common denominator. Okay, let's see here. Got another one. I know you're excited. I got all kinds of papers here. I lost my place. Okay. Okay, let's do another one. One more section after this, you guys. One more section after this. 7.3. And then I will do a video of an exam review. And in that video of the exam review, we're going to talk about the exam. So you definitely want to tune in for that. Okay, which one did we just do? Yeah, no, okay, we didn't do this one, okay. Okay, so I look at this, and I got to do it by completing the square, so I know I have to move the 5 to the other side. I do that by subtracting. So I'm going to have 4p squared plus 8p plus whatever that's going to finish that out, right? So half of 8 is 4. 4 squared is 16. Do it to both sides. Oh, wait a minute. What did I forget to do first? That's right. I forgot to divide by that 4 because I'm in a hurry. I got excited thinking about we only had one more section after this. My apologies. Okay. We'd still start out at the same place, though. We're going to want to move 5 to the other side. So the first thing we're going to do is we're going to move the constant. Then after we move the constant, then we're going to go ahead and divide through by the 4. After we move the constant, we're going to divide through by the 4. So yeah, we're going to have another fraction. So 4 goes into 4, leaves us with p squared, plus 4 goes into 8 twice. See, you can't figure out, you can't take half of the x term if you have a coefficient that's other than 1 right here. You have to divide through by that first. If I would have looked here and I would have said half of 8 is 4, 4 squared is 16, that's not going to give me the right answer, because what I really need to consider is down here. After I divide through by 4, my x, or my p term right here, is 2. Half of 2 is 1. 1 squared is 1. What I add to one side, I have to add to the other side. See, so after you do a few of these, you're going to see you do the same thing every single time, over and over again. So let's rewrite this. We got p squared plus 2p plus 1 equals, we've got negative 5/4 plus 1, or we could write it as 4/4, because remember, 4/4 equals 1. Correct? Yes, it does. And I'm writing it like that so now I have a common denominator. So now that I have a common denominator, look, I can simplify this. So I have negative 5 plus 4, and that's going to give me negative 1/4. So this is like my work that I don't know how to like tell you. This is just the work I'm doing. This is going to be what I'm going to start using now on that side. I just showed you the work right here. That's where my negative 1/4 came from. So now I can go ahead and I can simplify this. I can clean it up, if you will. So this is going to give me what? P plus 1 squared equals negative 1/4. Okay, so what should I do next? I know, you're sitting there going, put a radical on there. I would, but look at this. Negative, right? Radical of a negative number for you guys is that. So if you need to work it out further to find that, that's okay, go ahead. But if you look at it right there and you're like, oh, wait a minute, I have a negative. When I take the radical of that negative, this is what I come up with. This is going to be your answer. You're more than welcome as soon as you see that to write that down. You don't have to go any further. I would venture to say that probably up here, when you simplify these two and get this negative 1/4, a lot of people are going to see that. So it would be perfectly fine to write this after that and not even go into those two other steps. Let's see, we got one more. You are going to have to put way more time in on this than this video is taking you to watch. You're going to have to. You're going to have to struggle with it, and you're going to have to work out the problems and get mad and get it wrong. It's just what you're going to have to do. You can Google it. Solving quadratics by completing the square. You can Google it. Okay, so the last one, this looks different because I like to work one of each type. Okay, so I look at that and it says solve, okay, completing the square, and I'm like, all right, to solve by completing the square, though, I can't have it in that form. What do I have to do? I'm going to have to go ahead and I'm going to have to FOIL this out, right? So x times x gives me x squared, and that's going to give me plus 3x minus 3 bug equals 2. So that's going to give me x squared plus 2x minus 3 equals 2. So now I'm back where the other problem started. The other problems you started right here. You were given this, and you had to what? Move this over so you could do your completing the square. This is taking you a step back even further. That's why we had to FOIL this out to begin with. Once we get it FOILed, now what are we going to do? Just like on the other ones, we have to move the constant. I'm going to have to complete the square. 2 and 3 is 5. Now complete the square. Half of 2 is 1. 1 squared is 1. If I add 1 to this side, I have to add it to that side. So I can go ahead and this is going to be x plus 1 squared equals 6. I have to take the square root. That's going to leave me the radicand on this side. Equals, I don't have any perfect squares in there. So I did not write down every single little thing on here. You're correct about that. So when I got here, I went ahead and instead of writing x plus 1, x plus 1 times x plus 1 equals 6. I kind of condensed it and I just wrote this. And then I went ahead and I did the radical right on that step. You can write out every single step if you have to do that. That's fine. If not, if you're like, I'm following you, lady, I don't need to write everything out, that's fine too. But nobody's going to be able to go from this to the answer. I should see some version of the work in everybody's. I got one thing left. What do? I'm going to move the 1. I have to subtract it from both sides. So that goes away, leaving me with x equals... Is there anything else I can do with this? No, I can't. I don't have any perfect squares in there. I can't break this down. So I could write it as 2 separate answers if I wanted to. It would look like this. It might have it written like this in the back of your book. Or you could just write it like that. This or that. This or that. One or the other. They're exactly the same. Okay, so you're going to have to spend time on this, because if you don't, it's going to kick your butt, and this is where your next math class picks up at. And if you're like, I don't have to take the next algebra class, well, your statistics picks up here. If you got to take physics, if you got to take any kind of science math, this is where they all pick up at. Once you get done in my class in 31, they expect this is where you are. And there's going to be a lot of people that are going to be behind a little bit, because truthfully, the first quarter of the semester, I end up tutoring people in 34 and in college algebra all over this stuff. So do yourself a favor, do well on the exam, and have a good start for your next class. Okay, so this is 17.2. We have one more section, 17.3. And that's where we're not going to be doing completing the square. We're actually going to use the quadratic formula, which some of you guys remember. So I'm going to try to get that done in the next couple days and get that up, so you'll be a little bit ahead before the exam, or before the test. You got the test. It'll give you another extra day or 2 to study for the test. Okay, I will talk to you soon.